Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll use the sine rule to find angles in non-right angled triangles. So of course we looked at this formula last time. This is the formula we use to find unknown sides using the sine rule. Now when we're finding unknown angles, people generally find it easier if we actually flip these fractions. So if you just remember this formula for sides, just remember to flip the fractions for angles. So we're using this formula here. People just find it's easier to solve using this formula. So let's look at an example where we're finding an unknown angle in a non-right angled triangle. So looking at this triangle here, we will find this angle here, x. So we can't assume it's a right angled triangle. It actually turns out that it won't be. We can't use SOHCAHTOA and normal trigonometry. Instead, we'll use this formula here. So remember, as I said in previous video, angle A needs to be opposite side A and angle B opposite side B and so on. So let's set up like this. So we have sine of the angle, doesn't matter what I call it, whether I call it A, B, X or whatever, over its opposite side, which is 5, that will be equal sine of B over its opposite side, B. That's the formula. So once again, we have angles on top of their opposite sides, just like we did in this formula here. So let's go through and solve this. So we'd start by multiplying each side by 5 to get rid of the fraction on the left-hand side. So then we get 5 sine 60 over 10. So as I said in the previous video, if you multiply a fraction by a number, you just multiply the top, the numerator. So now I don't want sine x, I want x by itself. So to do that, we need to undo sine. We need to use sine inverse. So this is actually the same as in right angled triangles in that whenever we're finding an angle, it's always sine inverse, cos inverse, or tan inverse. So here, sine rule, it's going to be sine inverse. So I'm just going to take the sine inverse of both sides. So x will be the sine inverse of all of that, of 5 sine 60 over 10. So we're going to put that in our calculator. Once again, you need to make sure your calculator is in degrees. So to the nearest degree, it's about 26 degrees. So, of course, I don't expect anyone to know what x is off the top of their head without a calculator. But one way you can sort of check, are you on the right track? Remember, shorter sides are opposite smaller angles. So the 10 is obviously longer than the 5. 10 is opposite 60 degrees. So this angle here would have to be less than 60 degrees because it's opposite a shorter side. And it was less than 60 degrees. So there we're done. Unfortunately, the video doesn't stop there. There's actually an ambiguous case only when you're finding angles that we now need to go through. So please pause and copy this down if you need. So we're now going to look at the ambiguous case. So ambiguous means like confusing or double meaning. It turns out sometimes when you're finding unknown angles using the sine rule, there is more than one solution. So why is that? Well, let's say I wanted to draw a triangle with these dimensions. A is equal to 4, its opposite angle 32 degrees, and another side equal to 7. It turns out here I have two sides but not the angle between them. I can actually draw two different triangles with these specifications. And one of those triangles will have a certain value for angle B, and the other triangle will have a totally different value for angle B, and that's what makes it ambiguous. So I'll start by drawing line B, which is 7, and angle A, which is 32 degrees. So if this is angle A here, the side opposite A will be side A. So I could draw side A like this over here or over here. So I could draw this side 4 or this side 4, right? So I could have drawn this triangle with those specifications, and I could have drawn this triangle with those specifications. So angle B in the first triangle is this one here. In the second triangle, it's this one here. Notice in the red triangle, angle B would actually be obtuse. It'd be more than 90 degrees. Whereas in the second one, it would be acute. It would be less than 90 degrees. So with just this information, there are two possible values for B. So how do you know this? Well, let's go through and actually find what B would be. So what we would have is, remember, angles on top when we're finding angles. So sine B, so sine of this angle over its opposite side, equals sine of A over its opposite side. So we're going to go through and solve it just like we did in the previous slide. So sine B is 7 sine 32 over 4. So B is just going to be the sine inverse of all of this stuff here. So I can just put that on my calculator just like I did in the example on the previous slide. So making sure your calculator is in degrees, you should get around about 68 degrees for B. So that is one possible solution. That's exactly what we did on the previous slide. So how do we find a second possible solution? So it turns out that if you're using the sine rule to find an unknown angle, if you have one solution, if there's a second solution, it'll just be 180 minus the first solution. So we find the first solution, the acute solution, as normal. To find the second one, we would just take our first solution and subtract from 180. So the first solution was 68, the second solution is 112. So if we drew the red triangle, B would be 112, and if we drew the green triangle, B would be 68. So both of these are possible solutions. How do you know when there are two solutions or not? Well, you check the second solution and see if it would make the angle sum more than 180. It is possible that B is 112. There's no reason it can't be 112. It's possible that B is 68. There's no reason it can't be 68. That's fine. So in this case, there are two solutions for angle B. I'm now going to tell you what will happen when there's only one solution. So again, please pause and copy this down if you need. So let's say I have a triangle with these specifications here. Let's now draw that. So here again, let's see if I could have an obtuse solution and an acute solution. So to find the first solution, we do exactly what we've done in the previous examples. We use the formula. So remember, when we're finding angles, angles go on top. So here, I want to find what is angle A. So sine of A over its corresponding side is equal to sine of B over its corresponding side. So we're going to do exactly what we've done in previous cases. We're going to times each side by 25 and take the sine inverse. So I'm going to skip straight to the answer here. This is what you should end up putting on your calculator. Now, if you put this in your calculator, the answer you get is around about 39 degrees. So that part hasn't changed. Coming up with the first solution exactly the same way we did in previous examples. So remember, we have to check now whether 180 minus our solution is a possible solution. So 180 minus 39 is 141. So what I'm saying is, if it was an acute angle, I'd have it as 39 degrees, and if it was an obtuse angle, that one there would be 141 degrees, okay? So you always get your first answer, subtract it from 180 to get your second answer. So now we just have to check, is the second answer, is the obtuse answer possible? In the previous example, there were two possible solutions, but here there's not. The reason is because if this angle was 141, I'd have a problem. 141 plus 54 is more than 180. I can't have the angles in a triangle being more than 180. I can't have 141 as an answer. Then the angles of the triangle would not add to 180. So this is not a possible answer. So in this case, there is only one possible answer for A. I know this is really confusing with the ambiguous case, so just find the first solution as we've done all the time using the formula with angles on top. Then, once you've got one solution, subtract it from 180. And then you need to determine whether this second solution is possible. If it's not possible, that will be because the angles add to more than 180. Otherwise, it is possible. So that's why this one had only one solution, and the previous example there were two solutions. Here, because the obtuse angle would cause the angles in the triangle to add to more than 180. That's why this was not a solution this time, yet in the previous example, the obtuse angle didn't add to more than 180, so that was fine, okay? Sorry it's confusing. Please let me know if you have any questions. Thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.